The story begins in the early years of World War II, a time when engineers, chemists, and field carpenters were fighting a second war most civilians never hear about. On the front lines, soldiers struggled, battled, and survived. But behind them, supply chains were collapsing under pressure. Ammunition shortages were rising, steel was tightly rationed, and every nation involved in the conflict was desperate to stretch the usefulness of the most basic building material. They had left wood. Timber was everywhere in the war effort. Entire barracks were framed with it. Ammunition crates were nailed together by the millions. Tool handles, storage racks, bridge planks, fuel containers, temporary outposts, all of them depended on simple lumber. But there was a major problem. Raw wood, in its natural state, is weak. It rots quickly in damp climates, splinters under stress, absorbs moisture like a sponge, and offers almost no protection against shrapnel or impact. For armies fighting in muddy trenches, tropical jungles, and frozen forests, this weakness wasn't just inconvenient, it was dangerous. So military engineers searched for a solution. They needed something that could turn ordinary wood into something tougher, stronger, and more durable without relying on precious metals that were already stretched thin. And that's where one of the most overlooked wartime innovations quietly emerged. A simple mineral additive mixed directly into paint, capable of transforming ordinary lumber into a hardened, water-resistant, fungus-resistant, and surprisingly impact-resistant material. Soldiers later joked that when you hit it, it felt like striking metal. That forgotten ingredient was borax, or more specifically, industrial-strength sodium borate dissolved into wartime paints. Most people today think of borax as the cleaning powder stored under the kitchen sink. But during World War II, chemists processed it differently. Quartermasters needed an additive that was easy to transport, compatible with existing oil-based paints, and simple enough that soldiers or field carpenters could apply it with no special equipment. So factories produced a stabilized sodium borate solution that blended smoothly into military primers and coatings. Once applied, something remarkable happened. The dissolved borate didn't just sit on the surface. It penetrated through the paint layer and bonded deep into the wood fibers. Inside the timber, it raised the wood's alkalinity, killing fungi before they could take hold. It repelled moisture, preventing the swelling and shrinking cycles that usually destroy outdoor wood. And as it dried, the solution crystallized inside the cellulose structure, making the wood noticeably harder and far more resistant to splintering. In the field, the results were undeniable. Soldiers reported that borate-treated crates didn't swell during monsoon seasons, didn't crack in freezing weather, and didn't get eaten by insects, even when half buried in swampy mud. For militaries that needed their supply lines to survive in brutal conditions, this was priceless. Tools lasted longer. Storage crates held their shape. Makeshift shelters stood strong against wind, rain, and impact. Some soldiers even claimed these reinforced crates could survive minor shrapnel strikes or ricocheting fragments. Not enough to stop a bullet, but dramatically tougher than untreated wood. Historians later noted that some of these World War II crates survived long after the war ended. Found decades later in surprisingly good condition. They weren't preserved because of luck. They were preserved chemically. To understand why this works, it helps to look at what borates actually do inside the wood. First, sodium borate disrupts fungal metabolism by raising alkalinity and blocking enzymes that rot-causing organisms rely on. This stops decay before it ever starts. Next, borates crystallize inside the lignin network, the natural reinforcing mesh that gives wood its rigidity, The crystallization tightens the structure, making the wood more resistant to impacts and internal cracking. Finally, borates repel and poison insects like termites and beetles. They don't just coat the surface, they seep deep into the fibers where insects attempt to chew. This combination, rot resistance, insect resistance, moisture resistance, and internal hardening, is why World War II field carpenters swore by the additive. And the most surprising part, the method still works today. Anyone who works with outdoor wood, whether on a homestead, in a backyard, or at a job site, can recreate this wartime treatment using materials available at any hardware store. Borate penetrates best when mixed into water-based carriers, but with the correct technique, it can also be dissolved and added to oil-based primers, just like the World War II formula, to replicate the wartime method. You simply dissolve powdered borax or boric acid in boiling water until the mixture becomes completely clear. That concentrated solution is then added in small amounts to an oil-based primer. The goal isn't to create a thick or gritty mixture. The goal is to create a thin, stable solution that sinks deep into raw wood before the paint cures. During World War II, the standard ratio was roughly 1 part dissolved sodium borate solution to 10 parts paint. Strong enough to be effective, but mild enough to preserve the integrity of the paint binder. For modern DIYers, that translates to adding about 1 cup of fully dissolved borax solution to a quart of primer. Stir well, apply the mixture directly to unpainted wood, let it dry, and then seal it with a regular top coat. The result is wood that resists rot and insects for decades. The practical uses today are endless. Someone installing a fence can treat the bottom ends of posts before burying them in the ground, giving them a rot-resistant base similar to wartime trench supports. A survivalist building a small cabin could coat the support beams to stop moisture from wicking upward during wet seasons. Gardeners can coat the inside of raised beds to prevent soil moisture from eating away at the boards. Even tool handles, axes, shovels, hammers last dramatically longer when treated this way. One of the biggest benefits is dimensional stability. Untreated wood constantly expands and contracts with moisture changes, which causes joints to loosen and panels to warp. Borate-treated wood absorbs far less moisture, helping structures hold their shape. That means fewer warped shed doors, fewer split boards, and fewer maintenance headaches. This technique isn't just a curiosity from the past, it genuinely solves real modern problems. And that brings us to the deeper lesson. Wartime innovation wasn't always about weapons, machines, or groundbreaking technology. Sometimes it was about simple, low-tech solutions designed to keep equipment functional and supply lines alive. The borate paint additive wasn't glamorous, but it prevented failures, extended the life of materials, and gave soldiers a fighting chance against weather and decay. Today, as lumber prices rise and extreme weather becomes more common, we refacing many of the same challenges how to make wood last longer without spending a fortune. The World War II solution is still one of the simplest. You don't need advanced sealants or expensive preservatives. You need a basic mineral, hot water, and a can of paint. This is the kind of forgotten engineering that deserves to be rediscovered, not because it belongs in a museum, but because it still works. If you want more lost wartime techniques, from heating systems to improvised construction methods, make sure to subscribe and share this video with anyone who loves history, survival, or practical old world solutions. There's a lot more hidden knowledge worth bringing back.